Hey guys, welcome back to my channel Asterix Solutions. So this video we are going to understand the working of the word count program in MapReduce. So last video we saw how the flow of the program would be. So this video we are going to actually implement it. So let's begin. This is basically how the code should look like for a simple word count program. What I am going to do is I'm going to write this code again for mapper and the reducer part so that we can understand this. And I'm using the edit plus editor here because I don't like the gedit part what I get in Linux. So it is more good for eyes if we do it here. So I say package com dot asterisk dot com dot asterisk, and then I need to do some imports. So for imports, I'm actually going to write only the logical part and I'm going to show you how the things work here. So I'm just copying my imports from here. So I have got IO exception, string tokenizer to break the string, int writable, long writable, text for passing the data. Now you guys are comfortable with what is int writable, long writable and everything. I'll recommend, if this is the first video you're seeing, please see the flow video for link which is in the description box. Then you've got mapper and reducer, the configuration, job, the input format, the output format, file input format, file output format, and the path file. Now, for my public class, I'm going to write it as word count job, my word count job, and inside my word count job, I'm going to write a static public static class map which extends mapper. And in the mapper basically you write what is your input key value and output key value. So this is a generic type where you write the input key value and the output key value. So here, as we did it in the last video, the data from the record reader to my mapper will be given using long writable. So here comes the long writable, and the value will be given, the whole line will be given in text, and mapper will emit the value in text and int writable, text and int writable. Okay, and for the class map there is an abstract method. So public void, there is a method by name map, and it takes basically three parameters, that is long writable, which is your actual key, then you have got text, which is your actual value, and then a context file. Now context is basically the environment variable which will be available for mapper, reducer and everyone. So anything you emit from mapper will be known to the reducer through context. So throws, and it throws what? IO exception, comma, interrupted exception. Okay, so my spelling is right. So what is the logic I'm going to write in here is, I have a file, I am going to get the text, and I need to find out the word count, how many times a particular word is repeated. Now for example, for my working here, I have downloaded, okay, I have went to Wikipedia and I copied the name of Sachin Tendulkar totally here in my file everywhere. So whatever was written there, I have just copied it. So I'm going to find how many times the word 11, test, everything is repeated for how many times in a big file like this. So for that reason, now what my logic says is, I have to first I have to take whatever value I am getting into a string. So here goes string line is equal to value dot toString. Once I find the line, I need to break it into the spaces because I have nothing to do here with the key part, which is my offset. So what I'm going to do here now next is string tokenizer is equal to new string tokenizer, and I'm going to pass line here. So in case if your value by default string tokenizer break on space, but if you want to break it on hash or something, let's say you have got hash value to be broken, you have to provide it like this. But as we are breaking it on space, we don't need anything to break it. Now while tokenizer dot has more tokens, it's the method. So what I'm going to do is I'm going to take this particular token, whatever I get, that is my, let's say, individual word. So string w is equal to tokenizer dot next token. So it will give me whatever is my next token in the string w, and I need to write that string in the context now. By what value? By 1, because we need to emit it as 111. as we discussed in our previous code, that dr1 br1. So same way, for doing that, what I'm going to do, I'm going to write text word is equal to new text, that is my individual text, and int writable 1 is equal to new int writable of 1. So I need not make the objects again and again for every single call, rather I will do it in a single way. So now what I'll do, word dot set w, so whatever word will be set in here, and now I can just say ctx dot write word comma 1. So for every single word there, I am going to write what, word comma 1. So every word, and it is emitted as 1 1 1 1 1 out there. Now this is how you write your mapper. So this is your mapper class. Next, let us write our reducer class. So for reducer, I'll just put up the spaces here so that it become more visible. Public static class reducer, reduce basically extends reducer, and as per hypothetical situation, the output or not hypothetical situation, but what are the keys I am going to get as input to the reducer is a text and int writable, and it is also going to emit text and int writable. So I have got the generic object here, and again public void, I have a abstract method reduce. Now what exactly will it use, because as per our discussion in the flow, the data of mapper is given to your shuffle and sort phase, which forwards it to the, which does what, convert your key and value pair into key and the collection of value. So what I'm going to get here is text as my key for each word, and but for value I'll get iterable of int writable. So if you remember the diagram we did in the angular bracket there, that 1 1 1 1 1, those values will be now sent here, and now you have got context ctx. Okay, now what I'm going to do here, I'm going to first define int sum is equal to 0, because here I'm going to add all the int writable values. And next is for int writable I colon, or let's say x colon values, and let us go more in depth. So if I want to fetch out the individual value, let's say int I is equal to x dot get. So we have done this earlier, that if you want to convert a writable class into a primitive, you have to fire x dot get method to fetch it back. And now I'm going to just say sum is equal to sum plus I. So it will give me the final sum of how much is my actual count, and I'm going to do what, int writable sum, okay, or I can say final count is equal to new int writable of sum. I already have my key here, which was supposed to be written there. So ctx dot write, and I'll just say final count. I'll just say final count. So this is how I write my reducer. So reducer will fetch the value, take the individual value. Now aggregation can be anything. Next time it will be like you find the maximum value. Next time it will be you find some minimum value or find the average value. So you have to take care in that iterable part here. Next is I need to write my driver class. Basically word count job is my driver class. So I'll just say public static void main string array args, and in my string array args, now writing the driver class code is a quite hectic stuff. I'm just going to copy paste it, and I'm going to explain it that for you. So yes, this is my driver class code, and I need to also throw the exception, and I'll show you also the changes I have done there. So I have to do what, throws exception. Configuration represents the resource files. It will represent your resource files. So configuration is representing the resource file you all have, and your core site.xml and everything required for working in the Hadoop cluster will be taken care by configuration. And based on that configuration, I will start my job. Now this job class actually represents the Hadoop job. This job class actually represents the Hadoop job. So every single stuff you do has to be first set on the job class, and based on that jobs, now you can see I'm trying to run this job on this particular configuration, and name of my, this is basically the name of my job which will be used for identifying when I'm running the this particular job. So this is basically the name I will be used by my cluster to identify my job. Now next is job.set jar by class. So when you submit the jar, it should know which class to find. I have changed the name to word count job, so I'll have to just add the job here. What is my mapper class? So it is map.class. What is my reducer class? It is reduce.class. You can see here I have got reduce, I have got map internal classes. Next, what is my output key class? So when the reducer is going to emit the output will be in text. What will be my output value class? It will be int writable. The data from record reader to your mapper will be given in text input format. The data from your record reader to the output file will be given in text output format. And now you write path of output path, which is when you run the file, you should know that what is exactly your output path. So that is going to be the first value. After I say that I want to run this Java file, so after I specify in my running code, there are going to be two command line argument. First one is going to be the input path. So that is where, this is how you let your application know that which is your input path, means from where you have to pick up the data set, and this is your output from path from where you have to write the output. Now this is again like an important concept. You can see in the comment also that deleting the output path automatically from HDFS so that we don't have to delete. This is actually what you can say a fail-safe part for Hadoop. Let's say 2 or 3 developers are writing some jobs and coincidentally they give the output path same. Let's say first one job was running for 2 hours and second person he starts the job and he puts this line. So what will happen now? The first one's code will be deleted. So that is not a good practice, but as we are doing in the classroom level, this is not a problem. This can be commented, it will work also without it. And after job wait for completion, so if I return it true, if I get my job is completed, the code will exit, and this is my total MapReduce code on how I should be running this. Now what I'm going to do is I'm going to copy this whole stuff, take it to my VMware. We have already set up our VMware, you know our Hadoop cluster, how to start it. So after, if you haven't seen that, please watch the video on how to configure Apache Hadoop on Ubuntu. So I'm going to just right click and open a terminal and say cat word count job.java. Okay, so my bad, actually I should have written, I have to first send it to desktop. So cd desktop and I say gedit word count job.java. So this is how you can also create a new Java file, or you can just copy paste the Java file. I paste it here, I save it. So on my desktop now I have a Java file. On my desktop I have my Java file. Now what I need to do is, I am not going to keep it here. I'm just closing the terminal, and meanwhile I'll let us start our Hadoop cluster. So to start that, if your Hadoop is 100% set, you have to just say start-all.sh. You have to just say start-all.sh. Meanwhile it gets started. Let us go back in our root folder or our home folder, and I create a new, see the file I created by mistake was here, so I delete this, and now I create a new folder, Hadoop jobs, and inside my Hadoop jobs I create a new folder by name word count, and inside my word count I should keep 2 files for my reference as a developer. First thing I should have my I should have my Java code, that is my word count job.java, and second is I should have my dataset file, which is sachin.txt in this scenario. So again, yeah, in my Hadoop job, let's say home, and I've got Hadoop jobs. So in my Hadoop job, what I'm going to do is just paste these 2 files. So I have the file here, and there are 2 to 3 steps I need to do before I can actually get this executed. So starting off with, first thing first, I need to put this file in HDFS. So now again, if you are not aware how to put up file in HDFS using terminal, please watch the series of 5 videos in the description box of how HDFS work, because without HDFS you cannot run your MapReduce codes. So I am going to start. Before, let me check on the other terminal if my Hadoop have started. It is starting yet. Once your Hadoop cluster have started, you can just verify it using JPS. So all my nodes are running fine. Now, next, if I want to put this file of sachin.txt, let's say I create first a folder in my Hadoop cluster, in my HDFS, let's say Hadoop FS hyphen mkdir. I have a table, I have a folder by name user. I have also a folder by name Asterix, and inside that folder I'm going to create a folder by name word count space. I want to create one more folder called as input inside word count. So I'm going to just put up a space extra and start working there. So word count slash input. So yes, if you get this type of, it's a warning, not a problem, unable to load native Hadoop library. That's not an issue. The form is created, or sorry, not the form, but the folder is created. Now it's time to move the sachin.txt from my Linux machine to my HDFS. So the command for that is Hadoop fs hyphen put sachin.txt from where, and I have to put it in my user slash asterisk slash word count slash input. So it's putting the file there, and now let's say, just to verify, instead of firing for input, I'll just change the command to -ls, and let me verify that sachin.txt actually exists there, so that my dataset file is there. Yes, so my dataset file is there. Next is just right click, open the terminal, and now I need to compile my Java file. But to compile my Java file, all the Java related things will be available with me, but int writable, long writable, text, mapper, reducer will not be available. So I'll show you where to find those. So to find those, you have to go in the place where your Hadoop is kept. So in my setup, I have kept Hadoop. Inside my setup, you can find a folder by name share. Inside share, you have got a folder by name Hadoop, and inside Hadoop you have got yarn, and from your yarn, not from your yarn, so you can find the jar file in share. Inside share you can go in Hadoop. Inside Hadoop you can go in client, and here you can find Hadoop common jar. So I am just copying it and I am coming outside here, and let's say I've named a folder. So I name a folder here by name jars, and inside my jars I paste my first jar file, that is common jar file. It sometimes become hectic to find where my all jar files are. So for your sake, I'm going to do what, in the resource zip, I'm also going to give you this 2 jar file, given that you are working on Hadoop 3.2, which is the same version I am working on. After that, you also need to find one more, which is your MapReduce. Inside your MapReduce, you have to find core, this file. So core jar, see all the others have some other names on it, core, client common, but I need client core jar. So I take this client core, and okay, again I'm going to paste it in my jars folder here. So these are the required jar files that I might need, and now it's time to compile the already written job here in word count. Now right click, I have to start the terminal and say Java C. Now Java C is the basic compiler command which we use for compilation, but here I need to use -cp. Now -cp is that ignore the other class path and use whatever I'm going to write in this double quotes now. So Java C space -cp, my jar files are kept in this folder. So this location is basically where my jar file is. I'm just going to say pwd enter, and this is the location where my jar files are kept. I just need to use it. So I copy this, and so once copied, I can Java C space -cp, and I paste it. Try executing it, /* double quote. So all the jar files required are there, so use those jar files. -d space dot space word count job.java. So I start compiling this. Okay, so okay, I made some code error here, that ctx while writing I've done some mistake. Okay, so in my Java code it says the error is on a particular line. Yeah, ctx dot write final count. I should also write the key value. It is always in a key value pair. So it found the right mistake. So I save it in my compiler. I again say I can just put up the up arrow, say Java C minus CP. Okay, again IO exception must be thrown or caught. Okay, I forgot to put up throws IO exception, comma, interrupted exception. Save it. I'll clear this. Up arrow, enter. Okay, I still have got problem. I made a spelling mistake here on interrupted exception. It should be 2R. I put up 2P. So 1P and 2R. So I save it. Up arrow. So I make the changes and now I try to compile. So once I compile, the code is compiled now. You might get a warning, but the code is compiled. So you can see the folder by name com, and inside the com you have got Asterix, and inside Asterix you have got your 3 files ready. Now once I go ahead, I have to make a jar file here. So the second step is, after you compile it, next step is to make the jar. Again right click, say open in terminal and say jar space minus cvf space word count dot jar space com folder. So this is basically the command for jar. What should be the name of your jar file and what folder should be jar. So once I do this, you can see here that a jar file is created. Okay, so now we are ready to run our code and deploy the Hadoop jar. So I'll just clear this and try to make this command prompt bigger. Okay, now my step is, how do I deploy my, this is how you deploy your Hadoop job. So Hadoop space jar space word count dot jar. So you specify what Hadoop space jar is the command through which you launch your job. Word count dot jar is the jar file containing the job. Next, which is your driver class. So com dot Asterix dot word count job is basically my driver class, and inside this I have to write my input file. So slash user slash Asterix slash word count slash input. Now let's say your input have only one file, not a problem. If you want to give all, you have to just say star. If you have, let's say, 10 files and you want to work only on one, you can just say sachin.txt. So either you can select one or you can let it go. And next is what, slash user slash Asterix slash word count slash output. So this folder will be created when you install or when you launch the job, and your output will be stored there. So let's hit the enter and launch our first Hadoop job. So I press the enter. It will take some time before it runs. Yeah, it will. The log files. See, this are the logs. Number of split created is 1. Mapper have started. Reducer have started. Yes. So now your Hadoop job is completed. So once your Hadoop job is completed, your final, whatever was your output folder, if the job has completed successfully, what it will have a file by name underscore success if it is successfully run, which will contain nothing, and it will also have a file by name part hyphen r hyphen 00000 if it is only one reducer. If you run more than one reducer, you will have a series of 00001 00002. Now you have got word count slash output. So if you go in here and say ls, now you can see there will be two files, you success and part hyphen r hyphen 00000. So to run this file or to check the content of this file, now you can just say Hadoop space fs space hyphen cat space slash user slash Asterix slash word count slash output slash part hyphen r hyphen 00000 and just press enter. So whatever is the content of this file will be displayed to you now. This is, now you can see this is my word count, how many times these words are repeated here. You see all the time my words repeated. Try series, translates, tournaments, hundreds, century, this all words will be obviously available in this. It's all words in that single file and calculated in very short time. So this is basically the power of Hadoop. This is how you run the code or MapReduce, whatever we learned earlier. This is how we deployed it Tendulkar, it is repeated for 92 times. Tendulkars is repeated only for 12 times. So this is how you run a word count job. I'm going to post the Java code, the data set, and the jar files, as well as a documentation on how to run this step by step with this video in the link in the description box. Also, if you're new to this, please watch our previous videos on how to configure Apache Hadoop. Thank you for watching this video. We'll be again like back with some new data sets on, we'll try to do it on MapReduce, and also now we are going to introduce you how to work with Cloudera for Hadoop. Thank you. Do subscribe.